Hello and welcome to the section, The Data Pipeline. So far we've explored how to load data into Python and process it to create a bidimensional numpy array containing numerical values. Now we're ready to immerse ourselves fully in data science, extract meaning from data and develop potential data products. So let's move on to the first video of this section that deals with an introduction to EDA, that is, exploratory data analysis. Exploratory data analysis, or data exploration, is the first step in the data science process. EDA is required to understand a dataset better, check its features and its shape, validate an initial hypothesis, and get a preliminary idea about the next step that you want to pursue in the following data science tasks. In this video, you'll work on the iris dataset, which was already used in the previous section. First, let's load the dataset with these lines of code. Great. Using a few commands, you've already loaded the dataset. Now the investigation phase starts. Some great insights are provided by the describe method, which can be used as in this small piece of code. For all numerical features, you have the number of observations, that is count, their respective average value or mean, standard deviation, minimum and maximum values, and some routinely reported quantiles at 25%, 50%, and 75%, the so-called quartiles. This provides you with a good idea about the distribution of each feature. If you want to visualize this information, just use the box plot method, as done here. And here's the box plot. If you need to know about other quantile values, you can use the quantile method. For example, if you need the values at 10% and the 90% of the distribution of values, you can try out this line of code. Done. Finally, to calculate the median, you can use the median method. Similarly, to obtain the mean and standard deviation, the mean and STD methods are used respectively. Let's do it one by one. Here's the mean. And then the standard deviation. OK. In the case of categorical features, to get information about the levels present in a feature, you can use the unique method. Here's the line of code to do that. To examine the relation between features, you can create a co-occurrence matrix or a similarity matrix. In this example, we'll count the number of times the petal length feature appears more than the average against the same count for the petal width feature. To do this, you need to use the crosstab method. As a result, you'll notice that the features will always occur almost conjointly. Consequently, you can suppose a strong relationship between the two events. Graphically, you can check such a hypothesis using this code and plot a scatterplot. The trend is quite marked. We deduce that x and y are strongly related. The last operation that you'd usually perform during an EDA is checking the distribution of the feature. To manage this with pandas, you can approximate the distribution using histogram, which can be done thanks to this simple line of code. As you can observe, we chose 20 bins after a careful search. In other situations, 20 bins might be an extremely low or high value. As a rule of thumb, when drawing a distribution histogram, the starting value is the square root of the number of observations. After the initial visualization, you'll need to modify the number of bins until you recognize a well-known shape in the distribution. We suggest that you explore all the features in order to check their relations and estimate their distribution. In fact, given its distribution, you may decide to treat each feature differently in order to subsequently achieve maximum classification or regression performance. That's all for this video.